A lot of junior engineers think trickle ventilators are just a small window detail. They're not. If you misunderstand them, you can misunderstand the whole residential ventilation strategy. By the end of this video, you'll understand what trickle ventilators actually do, how Part F treats them, and the mistakes that catch junior engineers out again and again. This video is based on Approved Document F Volume 1, 2026 edition, so always check the full guidance for project-specific compliance. The reason trickle ventilators catch people out is because they look simple. They are small, they sit in the window, and on a drawing they can feel like a minor note. But in residential ventilation design, they are not just a product detail. They are part of the actual air strategy of the dwelling. Approved Document F is built around three key elements working together: extract ventilation, whole dwelling ventilation, and purge ventilation. If you are early in your career, that is the first thing to lock in. Trickle ventilators sit inside that wider logic. They help support the background supply of air into the dwelling, while extract removes pollutants from wet rooms and purge ventilation deals with short-term peaks when rapid clearance is needed. So the first big misunderstanding is this: trickle ventilators are not there for purge ventilation, and they are not there to replace extract. They are there as part of the background ventilation strategy. The second thing junior engineers often miss is that Part F sizes these ventilators using equivalent area, not free area. That sounds like a small technical detail, but it matters a lot. You cannot just look at a grill size or a vent size and assume it complies. The manufacturer data has to state the equivalent area in square millimeters. The guidance also says that background ventilators should have their equivalent area clearly marked where it can be seen from inside the dwelling. That means when you are reviewing window schedules, product data, or marked up elevations, the question is not just, does it have a trickle vent? The real question is, what is the equivalent area, and does it align with the strategy being used? For natural ventilation systems, Table 1.7 gives the minimum equivalent areas for background ventilators. In a multi-story dwelling, the minimum equivalent area is 8,000 square millimeters in habitable rooms and 8,000 square millimeters in kitchens. In a single-story dwelling that increases to 10,000 square millimeters in habitable rooms and 10,000 square millimeters in kitchens. Bathrooms need 4,000 square millimeters. Utility rooms and sanitary accommodation do not have a minimum in that table. But this is where people make another mistake. They think the check stops at room size. It doesn't. The same table also sets a minimum number of background ventilators in the dwelling. A one-bedroom dwelling needs at least 4 ventilators in the habitable rooms and kitchen. A dwelling with more than one bedroom needs at least 5, and if the kitchen and living room are open plan, at least 3 ventilators of the same equivalent area as the other habitable rooms should be provided in that open plan space. So now you can see why this topic gets misunderstood. You are not just checking whether one room has a vent. You are checking the room-by-room requirement and the overall dwelling arrangement. Another easy trap is assuming that Table 1.7 works for every layout. It doesn't. The document itself warns that expert advice should be sought in cases such as a dwelling with only one exposed facade, a dwelling where at least 70% of openings are on the same facade, or a kitchen with no window or external facade through which a ventilator can be installed. That means the prescriptive table route has limits. If the layout is awkward, you should not just apply the simple rule and move on. Now let's look at continuous mechanical extract ventilation, because this is another place where junior engineers often get the wrong idea. Some people think that once you move to a continuous mechanical extract system, trickle ventilators are no longer needed. Paragraph 1.64 makes it clear that this is not the case. If continuous mechanical extract ventilation is used, background ventilators should not be in wet rooms, but they should still provide a minimum equivalent area of 4,000 square millimeters for each habitable room in the dwelling. That is a really important design watch point. The requirement changes, but it does not disappear. There is also a practical coordination issue that gets overlooked all the time: air transfer through the dwelling. Even if you size the trickle vents correctly, the air still needs a path to move through the internal spaces. Paragraph 1.2. 1 says internal doors should allow air to flow by providing a minimum free area equivalent to a 10 mm undercut in a 760 mm wide door. The door should be undercut 10 mm above the floor finish if the finish is fitted, or 20 mm above the floor surface if it is not yet fitted. That means a ventilation strategy can look compliant on paper, but still perform badly if the transfer path has been forgotten in detailed design or site installation. So if you want the simple way to remember trickle ventilators, think of them like this. They are not a decorative slot in a window. They are a designed airflow component that supports the background ventilation strategy of the dwelling. They have to be selected using equivalent area, coordinated correctly room by room, checked against the overall dwelling rules, and considered alongside internal air transfer. And one final reminder, trickle ventilators are not a substitute for purge ventilation. Approved Document F says each habitable room should have purge ventilation capable of at least 4 air changes per hour directly to the outside, either through openings such as windows or doors, or through a mechanical extract ventilation system. So a background ventilator and a purge opening are doing different jobs. So the next time you review a drawing, don't just ask whether there is a trickle vent shown. Ask what ventilation strategy is being used. Ask what equivalent area is being provided. Ask whether the room-by-room and dwelling-wide requirements are both being met. Ask whether the internal transfer path works. And ask whether someone has wrongly assumed a small vent solves everything. That is how you move from reading the drawing to actually understanding the design. If you want more breakdowns like this for junior engineers, subscribe to The Lazy Engineer. And in the next video, I'm going to walk through the Part F mistakes that look minor on the drawing but can quietly break the ventilation strategy